Hi friends, welcome back to the course. So today we will be doing a solved example from GATE 2015. So as usual, I would recommend you to read the problem very carefully, because once you read the problem very carefully, once you understand it, half the problem is done. So pause the video and try to read the question very clearly, and if possible try to make a sketch as well. Hope you have read the question. Now, so we are talking about a single degree of freedom system which is subjected to a sinusoidal force of 10 Newton in amplitude. They are telling the frequency is given as omega. They are not explicitly providing any value for omega. This is fine because we will see what will happen. So let's say your system is getting excited by a sinusoidal force of frequency omega along the axis of the spring, one dimensional. The stiffness of the spring is given, damping factor is given. Very careful. What is this quantity given? It is damping factor. It is zeta. It is not coefficient of this particular quantity is damping factor, while this particular quantity is the coefficient of damping factor, coefficient of viscous damping. Okay, so clearly understand what quantities are given. Then undamped natural frequency. What is undamped natural frequency? Undamped natural frequency is your natural frequency, which can be given by omega n. So omega n is given in terms of the forcing frequency, which is 10 times omega. Clear? The other very important point to be noted is that they are asking you at steady state what is the amplitude of vibration. Units they are asking in meters. So be very careful. Whatever you do, make sure your final answer is in meters. Very important. Okay, now it's time to start using the concepts which we have already seen, which we have already learned. So in the figure I have shown a single degree of freedom subjected to a general excitation force in the form like this. This is general excitation, and its corresponding response is also shown here, where delta static is the static deflection, g of I omega is your frequency response. Then the response is lagging the excitation by an m on phi. I'm not writing the formula for phi here because that is not of much relevance to this problem. But what is of relevance, they are asking us to calculate this particular portion, which is the amplitude portion. So we need to calculate the product of these two terms, where g of I omega is given by the formula shown here. I keep saying it all the time, don't ever forget to put a square here, because this is a usual mistake we generally make. So now coming to what is given in the problem, they are saying your frequency of excitation is omega, then your natural frequency is 10 times of that, then your frequency ratio is 1 by 10, because frequency ratio is nothing but omega by omega n. Then they have given the spring stiffness, then they have given zeta that we already discussed, and magnitude or the amplitude of the excitation force is also given. Now all quantities to compute mod of g of omega is given. So let's go ahead and compute modulus of your frequency response. Okay, so now first is computing the static deflection. Static deflection is the amplitude. So appreciate static deflection physically. So I'm giving there is no harmonic excitation or sinusoidal excitation. I'm just applying the magnitude and just measuring what is a static deflection. I'm applying this amount of force as a static force, as a time independent force, as a time independent force I am applying this. Okay, then this is your spring stiffness. Then simple computation, this is in Newton, this is Newton per meter, very important. Now this 0.6 0.6 not 67, the units will be meters, so I forgot to put it there. So this is meters. Now computing the modulus of frequency response. Look at this closely. See, I made this mistake. I just 1 minus r I took. I didn't take a square. So always make sure you don't do mistakes of this kind. Then it's simple. Once you put in, now you know all the values. You will now, after turning this mathematical crank, you will get the answer. So here is the answer. Now your magnitude of frequency response is this much. Now you've been asked to compute the magnitude of the amplitude, which will be the product of these two quantities, which is this. What are the units? Again I forgot, but these units are in meters. Now in the question you won't be able to see this. They are asking you approximately, so you have to pay attention to each and every word in the question. They are asking you what is the approximate value of the amplitude. So the approximate value will be this much meters. Be careful, because this is option C, so option C is the right answer. Be careful, if you don't use your units correctly, then you may end up with the wrong answer, because there is a 0.7 also there in the answer. So be careful while manipulating your units. So thanks for watching. That's it.